Today we are going to discuss about JVM architecture. The JVM is a Java virtual machine which contains class loader, memory areas allocated by the JVM, execution engine, and native method interfaces. JVM is an abstract machine. It is a specification that provides runtime environment in which Java bytecode can be executed. So in JVM, the JVM provides runtime environment for us for executing the Java bytecode. So that means Java bytecode can be executed only in JVM. JVMs are available for different kinds of many hardwares and software platforms. So the JVM is platform independent. Now let us understand the structure of the architecture of JVM. So let us understand the class loader architecture of JVM. The class loader is a subsystem of JVM which is used to load class files. Whenever we run the Java program, the class loader will load the classes. That is, class loader loaded first by the classes are loaded by the class loader first. So the class loader again contains three built-in class loaders. What are they? One is bootstrap class loader, extension class loader, and the third one is system class loader. What is the bootstrap class loader and what does it do? A bootstrap class loader is the first class loader which is the super class of extension class loader. So bootstrap class loader is a super class of extension class loader. That means extension class loader is derived from bootstrap class loader, and it loads .jar files which contains all class files of Java standard edition. So all class files means, like in Java standard edition we are having so many built-in classes. Like in Java packages, java.lang.package contains some predefined classes, and .NET package contains some predefined classes, and util package contains some predefined packages, IO package, SQL package, like that. So all the classes which are predefined that are provided by the standard edition are all present in bootstrap class loader, and they can be loaded by the bootstrap class loader. Extension class loader. So already we have seen that in bootstrap class loader, extension class loader is a subclass of bootstrap class loader. That is, this extension class loader behaves as a child class of bootstrap class loader. The bootstrap class loader became and behaves as parent class of extension class loader, and the system class loader is the subclass of extension class loader, and this extension class loader loads the jar files which are located inside the JRE lib directory lo unde class files are loaded by the extension class loader. And the next one is system class loader, and it is also said to be application class loader. The application class loader is the child class of extension class loader. It loads, what does it do? It loads the class files from the class path. The class files which are available from the class loader, from the class path, can be loaded by the system or application class loader. So the application class loader loads all the class files which came from the class path. So by default, class path can be current directory only. In general, class path is defaultly set to the current directory. If we want to change the class path, we can use the command cp, or else you can use class path usage, or else we can use cp command. It is also known as application class loader. The system class loader is also known as application class loader. So ultimately the class loader will have three built-in class loaders. Those are bootstrap class loader, extension class loader, and system or application class loader. Bootstrap class loader is the first class loader, and which is a super class for all the class loaders, and it loads all the jar files which contains all the class files of Java Standard Edition. Java Standard Edition so manaku predefined all the class files are loaded from Bootstrap class loader. Bootstrap class loader will load all the class files which are provided by Standard Edition, Java Standard Edition classes, predefined classes. And now coming to the concept of extension class loaders. So this extension class loader is a child class of Bootstrap class loader, and it loads all the jar files which are located inside the JRE only. So inside Java there is a JRE file. In that JRE file there will be a lib. In that lib file with some class files are present. Those class files which are present in ext directory, there can be again the classes which are present in that directory will be loaded by the extension class loader. And the third one is system class loader, and also it is known as application class loader. It is also an extension of, or it is also a child for extension class loader. It contains all the classes from the current class path. Current class path nunchi class path edaithe which we are working, that class paths class files are loaded by this system class loader. So all the class path by default may be the current directory. If we want to change that directory, then we can change the class path directory by using cp command or by using the class path. So all these are all the internal class loaders which are provided by the JVM. If we want to create our own class loader, then we need to extend the class loader class to load some class loaders into our software. The another one is class area. The another one of the another unit of JVM architecture is class area, which is of method. Class area which describes some methods of the class. So then it is called as class area of methods. So class area methods stores class structures as per stores data as per the class structure. The class structure which is defined by the programmer, by us, can be according to that only method area for the classes can be allocated. So as per the runtime constant pools, and as per the fields, and as per the method data, and the codes for the methods which are present in the class structures, according to that only method area for the classes can be allocated. And the third one is heap area. It is the runtime area in which objects are allocated. It is the runtime area that is provided by the JVM to allocate memory for the objects. And the fourth one is stacks. Java stacks generally stores frames. It holds local variables and results and plays a part in method invocation and returns. Java stacks stores frames and it holds local variables, results, and plays a part in and plays a role. Generally it's a role. It plays a role in method invocation and return statements and returning the values. Each thread has its private JVM stack, and that stack will be created at the same time the thread is created. When we are having some threads, each and every thread in JVM will have its own stack, and that stack will be created at the time that thread is created. A new JVM frame is created each time a method is invoked. When we are invoking a method, new JVM stack will also be a new frame will also be created at the time of method is invoked. A frame is destroyed when the method has completes its invocation tasks. When the method has completed its execution, then the frame will also be destroyed. And the fifth one is program counter register. This is also known as PC registers. So the PC register is nothing but program counter register, and it contains the addresses that are provided by the Java virtual machine for the currently executing instructions. So the presently executed instructions of Java virtual machines are provided, their addresses are available in PC registers. Okay, PC registers are also nothing but program counter registers. And the last one is native method stack. Sixth one is native method stacks. It contains all the native methods that are used in the applications. When we are doing applications in Java programming languages, the native methods are nothing but predefined methods. The predefined methods provided by JDK or Java software, the native methods which are provided and used in the program in the application are contained in which are used in the application are available in native method stacks. Native method stacks contains all the native methods used in the application. And the seventh one is execution engine. So the most important one, the execution engine. The execution engine contains a virtual processor, an interpreter, and a just-in-time compiler. An interpreter, what the interpreter do? Interpreter read bytecode stream and then it executes the instructions. Interpreter will read the bytecode that is generated, and then that executes the instruction. Next one is JIT, just in time compiler. JIT means just in time compiler. So that what the just in time compiler do? It is used to improve the performance. Just in time compiler parts of the compiles, just in time compiler, that is the JIT compiles parts of the bytecode that have similar functionality at the same time. So if we are having same functionality in some methods, so the similar functionalities which are having in that bytecode can be executed at the same time by JIT. So that provides execution, that accelerates the execution. Hence, it reduces the amount of time needed for compilation. So here the term compiler refers to a translator from the instruction set to a Java virtual machine to the instruction set to a specific CPU. The term compiler, just in time compiler lo, the term compiler refers translator from instruction set of JVM to instruction set of specific CPU. So that's why here JIT compiler, just in time compiler lo, just in time means just in time at the same time. Compiler means transformation of code from JVM to the specific CPU. Instruction set, transformation of instruction sets to JVM to the specific CPU. So what ultimately the JIT do? JIT compiles the parts of the bytecode that have the similar functionality at the same time. At the same time, it will compiles the bytecode. And the final one is eighth one is Java Native Interface, JNI. Java Native Interface is a framework which provides an interface to communicate with another application written in another language. It is used to communicate with another application which is written in different language also, like C, C++, and some assembly languages, etc. So Java uses JNI, that is Java Native Interface Framework, to send output to the console or to interact with OS libraries. So the output for the console can be sent by the JNI, and if whenever necessary, the interaction with the OS libraries can also be done through JNI. So as a whole, the architecture of JVM contains 8 units, 8 different parts. The first one is and class loader, and the second one is class method area, and the third one is heap, fourth one is stack, fifth one is program counter register, sixth one is native method stacks, and the seventh one is execution, and lastly eighth one is Java native interface. Thank you.